Hi guys, good morning. Today we're going to be taking a look at page 6 and page 7 of the Unit 9 classwork packet. Once again, that's page 6 and page 7 of the Unit 9 classwork packet. Alright? Now, if you guys have me on B-Day, chances are you actually did see this right before we left. If you guys have me A-Day, I don't think we got to this. This was the plan for the Monday of the week school was closed. So I apologize for that. That's why I'm going to make this video so we can go back over the topic. All right. Now the topic for today is 45, 45, 90 and 30, 60, 90 special right triangles. To understand why we're going to be learning this, we have to take a step back for a second. All right. You don't need to write any of this down, but I want you to remember the big ideas. Previously, we learned that when we had a right triangle, if we knew two sides, we could find the third side by using my favorite theorem ever, the Pythagorean theorem, right? So Pythagorean theorem required two sides. Problem was, sometimes you were given right triangles where instead of being given two sides, you only had one. Now, the nice thing is though, let's say this is like 20 degrees, if you actually have one side and you know one of the acute angles in a right triangle, that's where trigonometry comes in, right? Sine, cosine, and tangent. Now, 45, 45, 90 and 30, 60, 90 degree triangles are really, really nice because instead of having to use our calculators, they let us find the exact values for sides. So instead of having to approximate and do like 7.2 or 8.3 or whatever the case might be, we can find the exact values. Now, if you're not quite sure after watching the video today how to approach special right triangles, the nice thing is, guess what? If you have a calculator, you can actually do it just using regular old trigonometry as well. But this is an alternative method that will help you guys do things perhaps a little bit faster. And for those of you guys going on to Algebra 2 and Algebra 2 Honors, it'll be in your best interest to know these because these form the foundation of the unit circle. Alright, so let's go over the basics. A 45, 45, 90 degree right triangle is exactly what its name implies. Alright, it's a right triangle where you have two 45 degree angles. Alright, so that makes it an isosceles right triangle. Now here's how this works. Let's say that I have one of the sides, which we'll call x. Well, because it's isosceles, the other leg is also x, and to get from the leg to the hypotenuse, all I have to do is multiply that leg by rad 2. Period. End of story. Super, super simple, okay? So if we take a look at example number 1 on page number 6, once again, what page? I should say page 6, question number 1. What they do is they give us one of the legs, right? They give us that this is 8, this is x, that's y. So all you got to do is realize, because it's 45, 45, 90, if this is 8, so is this. And to get from a leg to a hypotenuse, all I got to do is multiply by, what do you think? By rad 2. So y is actually 8 rad 2. Now, of course, you could have done this problem using probably either Pythagorean theorem or regular old trigonometry, but just so you guys know, it's actually much easier by using special right triangles. All right? Now, a slight variation on this problem is number 3. So let's take a look at number 3. Number 3, let me write that here. Number 3 is a little tiny bit different, only because instead of giving us our leg, they give us our hypotenuse instead. Well, let's think. If it's a 45, 45, 90, to get from a leg to the hypotenuse, I have to multiply by rad 2. So if I given the hypotenuse and I have to go the other way around, what's the opposite of multiplying? Oh my gosh, dividing. So all I got to do to get from the hypotenuse, 19, back to a leg, which is either x or y, is just divide by rad 2. Now, this is considered to be bad style to have an irrational number like rad 2 sitting in the denominator, so I'm going to rationalize it. What it means to rationalize the denominator is to simply make it a rational number by multiplying both top and bottom by the radical. So I'm going to multiply top and bottom by rad 2. What's rad 2 times rad 2? Rad 4, which is just 2, and 19 times rad 2 stays as 19 rad 2 over 2. All right, so that's pretty much all there is for 45, 45, 90 degree special right triangles, okay? Now, the other one, the 30, 60, 90, is a little tiny bit more complicated. So let's take a look at that for a minute. All right? Let's take a look at that. We are now on page number 7 of the Unit 9 classwork packet. Okay, page number 7. All right, so what is a 30, 60, 90? Well, as its name would imply, a 30, 60, 90 has a 30, a 60, and a 90 degree angle, right? So it actually kind of makes sense why it's called that. Now, across from the 30, we're going to call that x, all right? That's our smallest side, or you could say it's the shortest leg. To get from the smallest, all right, so the one across from the 30 to the hypotenuse, all you got to do is multiply by 2. So this would be 2x. And over here, to get from the small to the other leg, or you could say to the middle, right, because it's the medium side, you just multiply by rad 3. Consider that for a moment. This diagram you're going to want to memorize, all right? This is definitely going to be on your Unit 9 test. It's definitely going to be helpful to you in Algebra 2. Yes, you need to know it. Let me say that again. What do you need to know? This diagram. Star it, put a circle around it, do something, because this is a must-know piece of information, all right? Now, to see how this is going to work, let's take a look at a few examples together, shall we? Let's start off with example number 5. What number? Number 5. So number 5, they give us a diagram that looks something like this. I know, my drawing's pretty bad. Ay, that's actually really bad. Let's try that one more time. All right, they give me a diagram that looks something like this. That's better, right? Okay. So I have 14, x, and y. Now the key here is to realize what I have so I can figure out the other pieces, right? All right, so I'm given the small. So I'm given the x, right? I'm giving the smallest piece. So to get from the small to the hypotenuse, all I got to do is multiply by 2. So that means that x is 28. And to get from the small to the medium, all I got to do is multiply by rad 3. So if that's 14, this right here is 14 rad 3. So it's actually not too difficult, right? Not too difficult at all. The hard part will be when I'm given something a little bit different. When I'm not given the small, let's say I may be given the hypotenuse or I'm given the medium, all right? So to take an example of that, let's take a look at number 8. Once again, what number are we now going to look at? We're going to look at number 8. Okay, so number 8, what does that look like? So I'm given a right triangle, right? No pun intended. Ha 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 ha. Okay, that's 20. This is x and that's y. Okay, now here's the thing, right? If this is 60, this is 30. And so what I've got is a slightly different situation. Instead of being given the small, they've given me the medium, right? Now to go from small to medium, I have to multiply by rad 3. What if I want to go the other way around? How do I get rid of a multiplied rad 3? Divide by rad 3. So to get from the 20 to the y, I'm going to divide by rad 3. Then I'm going to rationalize by multiplying top and bottom by rad 3. And I get 20 rad 3 over rad 9, which is just plain old 3. So this right over here, as weird as it looks, is 20 rad 3 over 3. And then to get from small to hypotenuse, what do I multiply by? Well, I just multiply by 2. So if I multiply this by 2, I'm going to get 40 rad 3 over 3. Oh my gosh, weird, right? What terrible numbers. Well, on the one hand, yes, but on the other hand, let's say you have an Algebra 2 teacher who's like me and doesn't like when you use calculators, right? This will be very, very useful, and there's less of a chance you have to worry about degree mode, radian mode, and all that nasty stuff that the calculator can, cause you to do wrong. All right? Now, the last one we're going to take a look at for now is a multi-step problem. All right? So if you guys look with me on page number 8, can everybody look with me on page number 8? We're going to take a look together at question number 20. Once again, we're on page 8, question number 20. Page 8, number 20. What number? Okay, so I'm being extra, right? Yeah. Okay, so here's what we got, right? There we go. And then we have a meh. And then that's 60. That's Y, Z, That's 32, 45, 45, 90, and x. Alright, so let's do some work here, right? Okay, first things first. If it's a 45, 45, 90 degree triangle, how do I go from a leg to a hypotenuse? I multiply by rad 2. So that's going to be 32 rad 2. If that's 32, right, and it's isosceles, this is also 32. So that means my hypotenuse is 32. To get from hypotenuse to small, I would just divide by 2. So 32 over 2 is 16. And to go from small to medium, just multiply by rad 3. So in sum, 2 models, 2 diagrams to memorize. Can you do it? Yes, I think so.